Welcome to the fourth lesson of current electricity. In this lesson, we will discuss about cells, internal resistance, EMF, and the relation between terminal potential difference and EMF. These are the topics for this lesson. You know a cell, and a cell has electrolyte, cell has two electrodes and in between there is an electrolyte. So cell gives out electricity. Okay. So when the electric current flows through the cell, the electrolyte of the cell offers a resistance to the flow of charges. This resistance is known as internal resistance. So what is internal resistance? It is the resistance offered by the electrolyte of the cell to the flow of electric current. Internal resistance we usually represented by the small letter R. Capital letter R we use for external resistor. Internal resistance. Of a cell. It is represented by small letter R. So when electrons pass through the electrolyte of the cell, the electrolyte offers a resistance to the flow of current. This resistance offered by the electrolyte is known as internal resistance. Internal resistance is the resistance offered by the electrolyte to the flow of current. Okay, so cell, how will you represent a cell? This is the representation of a cell. Internal resistance we draw in series. This is the internal resistance. Okay, this internal resistance is the part of the cell. So I am putting in a dotted box. We can draw internal resistance under the cell also in this way. This internal resistance, what are the factors on which internal resistance depends? The internal resistance of a cell depends on the separation between the electrodes. Separation between the electrodes, if it is more, internal resistance will be higher. Second thing, it depends on the nature of the electrolyte. For different electrolytes, internal resistance will be different. Internal resistance depends on temperature. As temperature increases, internal resistance of a cell decreases, because as temperature increases, mobility of ions will increase. And internal resistance also depend on the area of the electrodes in contact with the electrolyte. So these are the factors affecting internal resistance of a cell. Factors affecting internal resistance of a cell. First factor is nature of the electrolyte. What is the second factor? Distance between the electrodes. As distance increases, internal resistance increases. Third one is area of the electrodes in contact with the electrolyte. If more electrolyte, if area in contact with the electrolyte is more, internal resistance decreases. If more area of the electrodes under electrolyte, internal resistance decreases. Fourth one is temperature. So these are the factors affecting the internal resistance of a cell. We can do it as an investigatory project. Okay. As temperature increases, internal resistance decreases. You might have observed that to car engine, starting of a car engine is easy in summer season. Winter season, we had to try more than one time. Why? In summer season, temperature is high. So the cell internal resistance will be less. Inside the cell, electrolyte. So current has to be drawn and it is used for the starting of the car. So in summer season, due to high temperature, internal resistance will be less. During winter season, internal resistance of the cell will be high. That is why it is easy to start a car engine during summer season. So this is about the internal resistance of a cell. Now we are going to learn another important concept called EMF, electromotive force. But the name electromotive force, but it is not a force at all. Okay, what is it? Let us see. Okay, see, when a cell is connected in a circuit, electrons, it has to drive the electrons through the complete circuit. For that, energy in the cell is used up. So the work done by the cell to draw a 1 coulomb charge through the complete circuit is known as electromotive force. Work done by the cell to drive a 1 coulomb positive charge through the entire circuit is known as EMF of the cell. EMF, electromotive force, it is not a force at all. What is it? It is the work done per unit positive charge. It is the work done by the cell to drive a unit positive charge through the entire circuit. Work done by the cell to drive a unit positive charge through the complete circuit. Okay. Now we can measure the EMF. How will you measure the EMF? you can use a voltmeter to measure the EMF. So we measure the EMF as the potential difference between the terminals of the cell when the cell is in an open circuit. That means cell is not drawing, not current is drawn from the cell. So you have to connect the cell to a voltmeter, okay, directly. So how will you measure the EMF? EMF of a cell is measured as the potential difference across the terminals of the cell when it is an open circuit. Open circuit means circuit is not closed. No current will be drawn from the cell. So how do you measure EMF? EMF is measured as the potential difference across its terminals when the cell is in an open circuit. Okay, so suppose this is a cell. You put a key inside. Key is a switch, and you connect a voltmeter. Okay, don't close this key. Then you have to measure the potential difference. See, this is connected to an external resistor. Okay, you connect a voltmeter here between the terminals of the cell. That voltmeter give you the EMF. You should not put the key inside the would not put the plug inside the key. The circuit must be open. So to measure the EMF, what we have to do? You construct a circuit like this, connect the voltmeter across the cell. Circuit should not be closed. You measure the EMF across the cell. That measure the potential difference across the cell. That will be the EMF. So EMF is measured as the potential difference across the terminals of the cell when it is in an open circuit. Okay. If the circuit is closed, when you put the key in a plug inside the key, the voltmeter will not give you EMF. That potential difference we call as terminal potential difference. Okay. So terminal potential difference is the potential difference across the cell when the cell is in a closed circuit. Okay. So we can differentiate between EMF and a terminal potential difference or potential difference simply. What is the EMF? EMF is the work done by the cell to drive 1 coulomb positive charge through the complete circuit. How it is measured? It is measured as the potential difference across the terminals of the cell when it is in an open circuit. What is terminal potential difference? It is also potential difference across the terminals of the cell when the cell is in a closed circuit. That is a difference. Another difference, the EMF is not depending on the external resistance of the circuit because no current is flowing. No current is flowing through the circuit. So EMF is independent of the external resistance. But PD or terminal PD depends on the external resistance because circuit is closed, the current is flowing. Okay. So this is the main difference between terminal potential difference and a EMF. Okay. Now we can obtain the equation for internal resistance. Expression for internal resistance. So I am drawing a circuit. EMF is E. Okay. There is a key connected here. This is the external resistance. Here, internal resistance, small r. External resistance, we use the letter capital R. This is external resistor. Okay. Put the key. Suppose current I. So how will you find out the current? Current is equal to EMF is the total voltage there divided by these two resistors are in series, R plus small r. This is the current flowing through the battery. Now, you know, potential difference across this external resistance, that is known as the terminal potential difference. That how will you find out? V, I into R. And this I you can substitute here. E divided by R plus R into capital R. From this, you can find out R plus R. That will be E divided by V into R. Now you can find out small r, internal resistance. E by V minus into R minus capital R. So you are getting capital R into E by V minus 1. So this is the equation for internal resistance of a cell. Capital R into E by V minus 1. Okay. So here E is the EMF, V is the terminal potential difference. Now we will write the relation between terminal potential difference and EMF. Relation between terminal PD and EMF. Terminal PD V, EMF E. So you consider the above circuit, or you consider the equation I equals E divided by capital R plus small r. If you cross multiply, E equals I into capital R plus small r. E equals I into R plus I into small r. E equals, this I into R is known as terminal potential difference. We write as V plus IR. Or we can write V equals E minus IR. See, this is the relation. Okay. So here in the previous circuit, the cell was discharging. The cell was discharging. Current is coming out of the cell. Okay. So when the cell is discharging, what is the relation between terminal potential difference and EMF? V equals E minus IR. So see, terminal potential difference is less than EMF by a term IR. V equals E minus IR. Terminal potential difference is less than EMF by a quantity IR. This IR is known as lowest voltage. So I into small r, that is known as lost voltage. That much voltage is dropped across the cell. Okay. So this is the relation between terminal PD and EMF when the cell is discharging. What is the equation? V equals E minus IR. The circuit is closed. So terminal potential difference is E minus IR. If you open the circuit, I will be 0. Then V will be equal to EMF. That was the definition for EMF. Okay. And if the cell is charging, what will be the relation? See, when a cell is charged by using another cell, the current move into the cell. So current direction will be negative. So for charging of a cell, during charging of a cell, what will be the terminal relation? Charging means the cell internal resistance. Here you are putting a key, external resistance. I no need of this diagram. See, this cell is being charged. Charging means you have to send the current through the cell. So current will move into the cell like this from an external higher voltage source. Okay. So during charging of the cell, current move into the cell. So what will happen? The current become negative. During charging of the cell, current moves into the cell. While charging, current moves out of, while discharging, current moves out of the cell. While charging, current moves into the cell. So I is negative. So what will be the equation for terminal potential difference? V equals E minus IR. So V equals E plus IR. Then terminal voltage will be more than the EMF. So remember, when the cell is discharging, terminal potential difference will be less than EMF. When cell is being charged, terminal potential will be more than EMF. So we learned what is EMF. What is EMF? It is the work done by the cell to drive a 1 coulomb positive charge through the entire circuit. What is the difference between terminal potential difference and EMF? EMF is measured as the potential difference across the cell when the cell is in an open circuit. Open means no current is drawn out of the cell. Terminal potential difference is the potential difference across the cell when the cell is in a closed circuit. Okay. So equation for terminal potential difference during discharging of a cell is V equals E minus IR. During charging, terminal potential difference is V equals E plus IR. Okay, children. So we will end the class today. Thank you for watching. Keep watching, share, and subscribe. Thank you all. Goodbye.